1 2 1 2. 1 2 1 2. 1 2 1 2 1 2. 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. Live session test. Oh, damn it. Live session test. Live session test. Live session test. Waiting for the video. Waiting for the video. No video. That's strange. No video, that is strange. No video. A, B, C, E, F, G. Live session, live session, live session. Okay, I can't see anything. Oh, okay, okay. One, two, 1 2 1 2 1 2 1 2 2 1 1 2 3 1 2 3 3 3 3 3 1 1 2 1 1 1 2 1 2 2 2 1 1 1 1 1 2 1 1 1 1 1 1 1 1 2 2 2 2 2. Okay, maybe made the okay, the mic now should be full at the full whatever, full value. Okay, let me check else the mixer. The mic seems to be full. Noise is louder. Is that better? Is that better? 1 1, is that better? 1, or still noise? Hey, still noise or not? Still noise or not? Okay. Yeah, it's a little bit hard to talk to a microphone. 1 2 1 2 1 2 1 2 1 2. I think I have increased everything I could. Okay. Yeah, that seems like everything. 1 2 1 2 rare mic. Oh, okay. Did it make? I'm not sure I have it, but okay. Okay, get it. Thanks. Okay. 8 minutes before we start. So, yeah. 8 minutes. Okay, let's try that. Oops, sorry. The first, okay. That? Is that okay? Did it make any difference? Nope. Leave it. Okay. Okay. So this time we have free music. We have, or not free, but Creative Commons music, which can be uploaded and will be uploaded to YouTube later today, I guess. Yeah, because everybody should enjoy creating free games, or not free games, but just creating. Okay. Okay, 5 minutes before we start. Checking the mic. Checking the mic. Yeah, seems to be okay. Yeah, that's our plan for the coming 3 hours. Yep. And initially, I mean, for the, let's see, the 3 hour, yeah. Hi. Okay, so to make these 3 hours happen, it took me about, let's see, 25 hours. Yeah, that was a good run for a few days, and that took me, oh, wow, about 4 weeks. Oh my god, that's a lot. Yeah, of course I had to fix a few bugs, yeah, to make that game happen. So yeah, that's why it took so many hours. Bugs like to appear when you make games or make anything for display to the audience. Yep. Okay, I hope this time, no, this time we won't have any bugs because I already fixed them, and I'm not going to go away from the plan far enough to have new bugs. So yeah, there should be no more, at least for in the coming 3 hours. How am I gonna remember? Well, while I was doing that long task for about a month and 25 hours, I've been recording what I've been doing, like doing, having bugs, fixing bugs, and then doing. Yeah, while I was first doing the game, I did record everything I did. So, yeah, I recorded everything I did, everything, and yeah, that's the plan now. What I've done before, I've recorded what I've done before, and that's the plan now. Yeah, it's possible. If not, we're gonna spend a little bit more time. Hopefully not. Yeah. Okay, 2 minutes. 2 minutes to go. I have launched also a Windows guest to show how to package a complete game without. That does not need an editor to run, just in case. Yeah, not in case, but because many people have asked me about it. Yeah, how to make a standalone game, and this how it will. This live session will end, I hope, in the standalone Windows game, and instructions how to create the same thing for other platforms, namely Linux and OS X. Okay. Okay. Let's have 1 minute. Okay, so it's time to start, and as I already mentioned, today's music comes from OGS Mahjong 1, the previous and the only game we have released in the wild so far. Yep. I mean, the real game, not a mini game like we are going to create today. It took a lot more months than this one to make. Okay, so the first question is the first question when you want to create a game is how to do it. So this project started as an answer to that, and today we are streaming our second live session, which gives an answer how to create a simple game with our tools. So the first question is where to get the tools. Currently you get it from here, and specifically for this live session I'm going to use the builds, which you can find by that link. As you can see, it has builds for Mac OS X, Windows, and 2 versions of Linux which were tested under Debian and Ubuntu. So it should run on Debian based Linux distros, and it may run on others, but I have not tested it. So if it does not run for you on Linux, you can either try Windows or Mac OS X build, or just build the editor from sources. Yeah. So okay, wait a second. Okay, so where do we start? Suppose, since I'm using an Arch Linux, a Linux distro that is not Debian based, as you can see here, I have built the editor myself. So yeah, I'm gonna run it from command line like that, and that's the ready game which is going to be created right now. So I already have the editor, and after you downloaded it from here, you would have the same thing. So for now, to create a new game, you have to do a few file manipulations manually. It will be fixed in future versions, but for now it's not it's not a button click. For now it's a bit of files moving around. So the first thing you need to do, the first thing you actually already done is downloaded the archive, unpacked it, and okay, to depict how this looks like, let's do that actually, because yeah, if I'll just be explaining, that won't make any good. So let's do the whole process under Windows, but I will do the actual programming under Linux. So this is Windows, this is the guest OS, and okay, I don't want anything. We go to sf.net, projects, OS, RPG creation, files, Then we go to the editor, then we go to the Jenkins, and then we go to the latest build as of now, and now is the 31st January 2016. So we go here and download it. Let's download it, I don't know, somewhere. Second. Okay, so as I already said, let's download the editor in Windows, and let's download it to, let's say, okay, desktop. Where else can you download anything? Yep, so let's download it. Yep, and here we wait, and oh, security download file. Okay, that was weird. Let's download it maybe. Yeah. Okay, old Internet Explorer is not user-friendly at all. Alright, let's try another one. Okay. Yep. Direct link. Yes, let's try direct link. Okay, finally. Let's save it to desktop. Yep, got it. Yep, finally. So, after we have downloaded, as I will show shortly, you'll have the editor, and in that directory you will also have the slidedown.ogs. That's the directory with the OGS project, the project that editor works with and modifies, and that's basically where the game is located. Okay, alright, a few seconds. Okay, got it. I have downloaded the archive. Here's the archive. I simply unpack it. You can unpack it, I guess, extract all, and just to desktop and go. Okay, looks like we had a problem with the stream because I have been downloading the editor, and that probably broke my outgoing connection. So yeah. Okay, now I hope you can see me. So we have downloaded the archive, and now we have extracted, unpacked it. So there's, for Windows and actually for all platforms, there is a run file. For Windows it's called run.bat. You just double click it, and the editor starts with the slidedown.ogs project. You can press space as it denoted here. It will say start, and the game will start. Okay, so you have that. Here's the slidedown.ogs directory, and that is the OGS project directory. It has models, pipelines, scripts, sounds, and some default files which need to be present for now, and some of them we will create right now. So to create a new project for now, you get the project, already working project that is opened successfully by the editor, and copy it. Alright, so since our game is called Rolling Ball, we'll create the directory called rollingball.ogs. Oh no, we won't create it. We will rather copy existing directory, slide down OGS into rollingball.ogs. Yep, ready. Let's make sure it works fine, just in case it does not, but it should. So rollingball.ogs, as you see, I have changed the path. Alright, that seems to work just fine. So yeah, all files have been copied successfully. Now what we do is we open the editor with that project and start removing everything. For example, we go through some nodes and remove scripts. Main script, okay, just main script, save it and quit. The main script is this script that runs the game, basically initializes many things. And main, it's called main because it's just it's not actually obligatory. You can call it whatever you like, but for consistency reasons I called it main. So what you do is start, okay, let me move a little bit away, so you see the ready project. So you go, you see, I can select things, objects, so you go and delete it, and delete it, and delete this, and this, and this, and I guess this. So camera should stay, light should stay, yeah, that's very important for now. If you delete those, the editor will crash. So you should leave, not stay, leave. Should leave light and camera alone. As you see, there's nothing in the just nothing. Alright, we also remove all scripts, so both light and camera. By the way, camera, no, we don't need that too. So the only thing we need to leave is the light node. Save it, quit, and let's check it work. Damn it. Alright, you can delete everything. You just saw that. Okay, let's get the scene, which is called default scene, back. It's, all the scenes set up is in one file for now, and it's called default scene. Okay, let's get it back and delete everything. Alright, let's delete everything but light and camera. Yep, once again we delete everything. Yep, delete everything. Alright, you probably can see that I delete everything, but I really do it. Delete, delete, delete. Also, no main script. Also, no camera sync script. So we have light and camera, and current requirement is that light, which is a special node, it should be named like that for now. And a not so special node camera, we can call it whatever we want, like box, but there should be a light and a box for the editor to open the project for now. Yep. God damn it. Now that's really weird. Okay, let's have a look what it looks like now. The file. That looks fine. That looks totally fine. Okay, I'm gonna do it the third time, and now I'm gonna remove things not so fast. First, remove all the scripts and a few tracks. Okay, maybe with a ball. No. Okay, let's remove and leave a little bit. Okay, let's recheck it. Okay, it runs. So somebody's causing me problems. Alright. Okay, let's remove that and leave the ball alone, maybe. Okay. Looks like I can't remove the camera, really. So, already forgot it. Okay, let's check it out. I have unlightened camera, and the ball is missing, and we fall. So we need actually 3 things, or no, 2 things. Okay, anyway, let's have 3 things and be done with it. Yeah, not so easy. So once again, we go and remove everything. Yeah, first steps are the hardest. Hopefully in the future versions, new empty projects will be created with a click of a one button, not many buttons like now. Okay, let's have 3 nodes left. Okay, that's better. We have light node, which is obligatory. We have camera node, which is not exactly obligatory. Yeah, let's keep the backup actually of the file. How to make a backup? Well, you just copy it in the backup default scene, just in case. I just want to check. Yeah, I'll just check. Let's create some empty node. Yeah, it wants the ball. Oh, it wants the ball. Okay, looks like yeah, somebody else like default actions. No. Okay, somebody's referencing the ball and wants it. And I know who. Default compositor. Okay, you want something. Yeah. So yeah, we need not only to remove the nodes, but also clear a little bit default compositor up to these 3 lines, which say just what texture template to use when we use the textures. When we reference the textures, it says like things like the width, the height of the texture to use, and that should alright. God damn it. Okay, let's bring the backup back. That's not interesting to find the bugs, so yeah. Here we go. Okay, we have the ball, but I don't want the ball. Okay, let's set the model to none, and let's set the material to none. Okay, let's check it out. It wants the ball and gets the ball. Okay, that. Okay, let's check it out, right? Okay, I get it. Okay, so we bring the backup again. And really the reason was because, yeah, so far the editor cannot handle an empty scene without any modal. Yeah, right. So non-modal, no. we can't have it. Box model, yep, box model is a standard model, and non-material is a standard material in a way. Okay, save it. Yep. Okay. Yep. And that's the way it is. Alright, for now, the new. Alright. I think everybody kinda is sleeping now by that time, so I'm gonna redo it because that's really awkward. So what we do, step number 1, we copy existing project into another one, call it rollingball.ogs. Once again, we check that it works. That's step number 2. Okay, that works. We do remove everything except light, except camera, and except ball. And ball should have any model, let's say box, because if you leave no model, the editor will crash, as you have already seen many times. Yeah, and code box, for example. Then remove everything else, everything else, everything else, everything else, and everything else. Okay, so we have the box only. In the scene, we finally save it again, quit, run, and that's it. And that's it. Okay. So that's the box, that's the light, that's the camera, that's the box. Alright, the second large step after removing everything in the editor, you have to clear a few things up, like default actions, because we will write them from scratch. Rewrite them. Yeah, we will rewrite them. So as you see, it's empty now. So let's check it works. Yep, that works. Okay, now default compositor. Alright, we only need that. 3 lines, which just say that we should use texture template for textures we do load. And texture template is something like, let me show you. That's in editor resources, and looks like this. Like this, actually. Yeah, it says things like repeat by S and T dimensions, which means like repeat the texture if object is bigger than the texture. Minification filter and magnification filter, and that its type is 2D. There are other textures too. So basically, that says like what to do with a PNG file. Nothing special. So we have cleared default actions, we have cleared default compositor, we don't have to clear default lights, because yeah, lights have to be manually written here for now. Default scene, as you saw, we have left 3 nodes: light, camera, box. And by the way, that format is called Pythonic ini, or short PINI. That basically says that this is a type node, this is a group default, and this is item name light, and these are properties of that light in that group of that type. So light has parent root, which means root. It has the following position, and it references the light named default, which is found in default lights. Yeah, the same structure, light default default. That's the name it references. And it has some parameters like jittering scale, fragment shader, and texture size to use for rendering. The larger it is, the better is the texture. I mean the shadow, the texture shadow, and the quality of shadows, but it takes more memory. We won't change it because that's pretty much hard-coded for now. So default scene, we okay. Default sounds, yep, we clear this too. Okay. Okay, I haven't checked if it works. Yeah, that still works. That's good. So we also have player shortcuts. For now, that should be left as is. That says that there is a shortcut for the player when it will load the project that we will shortly create with the editor. That there is a shortcut in the group node that is called select, and its shortcut is, which is hotkey, left mouse button. So that means that a player will detect left mouse button and will report that select shortcut have been activated, and that allows us to bind any key to any action basically with the just one file. For now, yeah, that's a file. In future versions, of course, it will be configurable from the editor or likewise. So let's go to modals and clear them up because we will redo them shortly. Okay, we remove everything in the modals. Let's check we still work. Okay, we still work. Okay, we still work because even though we reference the box model, the box model is located in editor resources, which you should never touch. So there's the pipeline directory, there are textures, and we remove everything too. We need no textures. Yep, that still works. Now there are scripts, and we don't need scripts. Or actually, we do need one script to make it easy. We will remove everything except for camera sync because that's more of an editor script than a game script. So, just a quick note how camera sync works. It will be moved to editor resources later. For now, yeah, I decided since this is the first time camera sync is used, I just left it in the project resources because that's the workflow we wanted to use originally. That is, we develop scripts first in projects and then they transition to core editor resources. So for that script, since it's pretty new, it appeared only in that 08 version of the editor. Yeah, it's still in the project resources. Alright, so we'll leave it here. That won't exist in the 09 version, it will be built in, so you can consider we have no scripts by now. Now we go to the sounds. Yep, we remove everything too. Let's check it out. That we still, yeah, that still works. That's perfect. Okay, and there's the src, and that's the directory where Blender models will be located. So we remove current ones, and we also remove the git directory, which contains git information, since we copied slide down OGS project, and that's at GitHub, so it contains the .git directory. We do remove it. Alright, let's force it. Okay. That's the list of all files. So default actions, empty. Default lights, left as is. Default sounds, empty. Pipeline, removed subdirectory textures. Files in the subdirectory textures. Then scripts, only left camera sync pi because that's more of an editor script than of the player. src source, that's where we will keep the Blender files. Then default compositor, only 3 lines left, which specify which texture template to use. Default scene, only 3 nodes left, light, camera, and box. Modals, nothing left. Player shortcuts, left as is, with shortcut to denote that when a user presses left mouse button, it will report selection shortcut. Sounds, left, cleared up, nothing, empty. So yeah, that's our empty project, and what we will do, we will commit our first commit. Commit our first commit. Yeah, that sounds weird. Alright. We will init a git directory here. Yeah. We will add everything. That's the commit, the repository that we will share after the live session, or you can actually get it right now, almost, once I commit it. Yeah, let's call it initial commit. Okay, let's create the new repository. Ah, damn it, I need to sign in. Okay. So, no. Okay, new repository. Yeah, let's call it rolling ball OGS. Rolling ball game created on 31st of January 2016. Yeah. It's public. Yep. Okay, so push, I do push an existing directory, so yep, we just copy these commands, execute them, and bam, of course, password. Alright. Okay. So go back to the GitHub, update. Here is what I have created so far. There's no need to download it now because that's pretty empty, but it contains something which can be called an empty project. Okay. I think next time we should create it beforehand, because that took like half an hour to figure out how to create an empty project. Not very user-friendly, but okay. So, as you can see, there's only a box. So, here's the plan. We created the project by copying, WAM, which is whack-a-mole.ogs, is the name of the previous minigame created in the previous live session. Alright, and stripping all unnecessary scene nodes and files. Yep, that's what I've been doing for half an hour already. Push it to GitHub, yeah, that was fast. And now we create models. We create the plane track part, the catching track part, the ball, the cleaner base. So plane track part is the part of the track that where the ball simply rolls down, and the catching part is where is the part where we can catch a ball. Not sure. I couldn't come up with better names, so yeah. So we open the Blender, remove everything. Yeah, hopefully the Blender won't crash. No, it won't crash, I already checked it. So we go to the rolling ball OGS, go to the source, because the blend files, yeah, the editor doesn't work with them. Let's go with models, because we will keep all models in one file for now, because it's not, I mean, there is only like 5 of them, so yeah, there's enough space for 5 models here in one file. Alright, so plain track part. Let's do this, and let's try to do this. We add the cube. Since I'm not great modeler, I do everything with cubes, and all tracks will look like prolonged cubes in a way. So we use metric for simplicity, because I'm not in the United States, so yeah, metric is used. Simple cube. Alright, so let's make it a little bit smaller by Z, like a little bit. Yeah, even less. Let's make it thinner a little bit by Y. Okay, that's better. Plus. Alright, reduce it again, and that looks almost like a track, isn't it? Doesn't it, I mean? Okay, that is almost a ready track. I could actually use that, but that's not cute enough, I guess. You can call it. So what we need is it will be 1 meter, or actually 2 meters, right? Yeah, it's 2 meters, right, by X. So it's 2 meters long. Okay, looks like a good size to me. 2 meters. No, let's make it even smaller. Like this? No. Like this. Yeah, that's better. Alright, so let's create the platform. Platform where the ball will land. Yeah. I think, yeah. So we extrude, move by X, by 1 meter. Here's the platform, or what will become a platform later. Yep. Alright, move it a little bit back, extrude again. Okay, that looks almost the way I wanted it. Do the same, make it a little bit shorter. Yeah, because, yeah, even more shorter. Yep. And here again. Yep. Now extrude that too. Yep. So I do that, extrusion at the edges, because I want borders. Yeah. This will do like, yeah, this will be good. Alright, so Borders or no borders? Okay, I wonder if I can make anything interesting with the borders. Let me have 1 minute. Maybe I can come up with something other than cubes, I mean. Okay, I can't come up with anything right now, so let's not come up, but just do it. Let's make it thinner. Yeah. It will still differ from the original, let's say, minigame that is shipped with the OGS editor 08. So yeah, that will be different. So okay, let's make the borders rise, I guess. Oh, by the way, let's call it the base plane. Base plane, yeah. That will be the base for all the planes, I guess. No, for just one plane. The upper part, which is just a rolling part of the track. Alright, but let's just copy it. Maybe I will just use it a little bit later. So now let's make the borders. Okay. Here border, yeah, we're gonna have here border and here. Yeah, that looks like a border. Yeah, that looks like a border. So again, one. No, wait, not here. Here. Okay, extrude. Move by Z, like, you know, by 1. No, by more. Yeah, these borders are better. Alright, we get the cubes again. Maybe someday we'll have something to model cute models for us, but not today. Yeah. Alright. Now, nope. Select by vertices. Move it down a little bit, and now the ball can roll down in a way. Yeah, that looks like a track, like a part of the track. Now let's move the center of the model a little bit here, so that is easier for later assembly. Or assembly, yeah. So that's track part number 1. Let's call it base plane part. Yeah, let's call it base plane part. Okay, the second part is the catching part, and we need borders too, but we need less borders. Okay, as you can see here, it can't go from here and then here. It only can go from here and then here. So, and I'm gonna make this part here, which is missing at the moment. So the ball will come like this, and then like this, and then like this. So there should be no border here. There should be no border here. Border here, yeah, and that's it. So basically just modify that. Alright, let's code base plain, no, base catch part. Alright. So select this, and this, and this, and yeah, this, and this. Extrude, move by 0.02, and these are our borders, I guess. Yeah, there was no that thing in the original game, I think. In the original slide down OGS project. So yeah, that's the difference now. That will be the difference. Now we do pretty much the same thing for to bend it down a little bit. Yep. Now the ball can slide here too. And that looks like a good second part, which is the catch part of the track. So change the center of the model for an easier assembly, and that's it. So we have two models, two base models, base plain part, base catch part. Alright, what else do we need? We also need the ball. Alright. Alright, let's make the low poly model out of this. The low poly model is the model we will use in the game directly. So let's call it like that. Not the base, but low poly. Low poly plain part, alright. Then the second one, okay, copy it too, and call it low poly catch part. Okay, and now we do copy base once again. No, we don't. We don't. So we have the base plain part, the base catch part. Now we have low poly plain part and low poly catch part. Now let's make it a little bit better by using by applying a simple modifier called bevel. 1 centimeter. As you can see, it smooths the angles, so yeah, that looks better in the game. Not as cubical. Not as cubical, yeah. Okay, we do the same for the catch part. Alright, that looks better. Now copy these models with the modifiers. This will be the high poly, plain part. And now copy the low poly catch part and call it high poly catch part. Alright, now let's apply the modifier so that it will change the mesh, because as you can see, the modifier is not really applied. It's just visible at runtime but not applied. As you can see, the vertices are still unchanged. So now we apply the modifier and change the mesh. As you can see, there are more vertices now. Now do the same here. Alright. Now let's change the shading a little bit. Select everything. And we only need to smooth the edges. So select everything but the edges. Yep. So I deselect everything that will not be smoothed. Alright. And I won't smooth, only the plane, the flat planes, because the edges should be smooth to look more real, because yeah, there are no knife like edges in real life on objects like this, because we're not making a knife, we are making a track that won't cut our ball. The ball should be intact. So yeah, smooth edges by deselecting everything that will be left flat. Alright, not as fast as I wanted, but I think, yeah, as you can see, only the edges are highlighted now. Yeah, I think I haven't missed anything, and even if I did, that won't be very. Ah, here's the one I missed. Yep. Now that looks correct. So I go to the shading and smooth the faces. As you can see, they're now smooth. And look better. Now do the same for this, for the second catch part. So we select everything and deselect flat ones. Alright, deselect flat ones. That's very interesting, of course, to do the same thing many times. Very, very interesting. That's like playing a minigame. Maybe we will create one day called shading faces or something. Yeah, not so easy. And the game might the game purpose might be to deselect really fast. Yeah, why not? That would be an interesting game for modelers, like if you can model a thing really fast. Like really, really fast. Since I'm not a modeler, that takes me some time and maybe not the best, and maybe I'm using not the best approach, like the way you see, to deselect something I won't operate on. Okay. Yep. Ah. Oh. Not so easy. Okay, I think I got it all. Okay, that looks correct. Oops. So now we shade the edges like smooth faces and smooth faces again. As you can see, the shadow is nice. Alright. Now we need to finish our high poly models. Well, we just do more smoothing in a way that modifier works. We simply tell it like modify it not once but 15 times, and 15 times is pretty much enough to make it look really slick. Yeah, that's fine, I think. Do the same for the catch part. Simply 15 segments. Now it looks good too. Yeah. So now, oops. Okay. Yeah. Now I need to export it meaning the modals, two modals, this one and this one, the plain part and the catch part, to the editor. So you do this by getting the OGS Expert plugin for Blender. It's somewhere here. Alright, OSG export. Open scene graph, right. So you can get it here. It's at GitHub, Cedric Pinson, OSG export. OSG is from Open Scene Graph, as you can see. That's the rendering engine and a bit more, which we use to render everything, to work with the input and much more. So basically what you need is a file like, I use that one, no, that one, or okay, I can't remember which one I use, so let's have a look. It's in Blender and I use the version 13. Alright, so yeah, that's the version you probably need. Yep. You get it, download it, and then you tell the Blender that you want to use it. You go to user preferences and somewhere here, yeah, in the add-ons you do install from file, you locate the file you have just downloaded, that one. You don't unpack it, you just select it in the Blender, and bam, it just works. Just works as in it appears here, so you just need to tick this thing, yep, like that, and it works. It appears in the file menu, file, export. So yeah, let's export to OSG model. Yep, we are in the rolling bow. Okay, go up. And now the first model is, let's say, okay, it's plain. Yeah, it's plain. So file, export, OSG model. Go to the models directory and export it as plain OSGT. OSGT is an open scene graph text format. There is a binary format, but we don't use it because I don't know, because you can edit it. So it looks like this. You don't need to do anything here. Also, you can check that it was exported correctly by using the OpenSceneGraph viewer. So that looks the way we wanted. So that means it has been exported correctly. Now export the second part, which is catch, I guess. Yeah, catch. Code catch. Catch. Export. Okay, we have exported two models. Catch OSGT and plain OSGT. Okay, we can actually use them in the editor now, and just to show that, yeah, we can use it. Okay, where's the box? Okay, come here. Okay. Okay, for simplicity reasons, we will apply the camera sync script I talked about before. It will allow us to sync the script for the editor for later use. So we could do like that, then do like sync camera to node, and bam, we save the camera position. Yeah. As I already told before in the beginning, camera sync script will be located later in the editor resources, and you won't need to care much about it. Well, maybe only select it. So here's the box, and we want to make it into the plain part. Plain, let's call it plain. Then select the plane. Okay, and that's the okay. There is one thing I forgot that needs to be done. As you can see, the lights were wrong, so we need also to create a UV map so the textures are mapped correctly. Yep. Do the same for the catch part. Select everything and do UV unpack. Save. Alright, we also need to re-export things. Alright, re-export it. Export model. We export. Yeah, that's the plain part. Export plain. Okay. And now export the catch part. The catch part. Alright, let's recheck it. Alright, now the shading is better. It looks ugly, but yeah, that's the default texture. Yep, I guess Blender has it. Maybe, yeah. Though I haven't worked with cinema, and I don't really intend. Yeah, Blender works fine for me for cubical things. So as you can see, yeah, that's the first part of the track. It's called plane. Let's add another node. We'll call it catch. Select the catch model. Move it around a little bit. I guess the Y. Nope. Yeah, move it a little bit here, like this. Blender for simplicity. Some people say it's not intuitive enough. Though, I'm not sure. I never use anything different, so alright, let's do precise tuning. A little bit up. Okay, that seems to be correct. Yeah, free Blender is a good one. Hopefully one day somebody will be creating a game with this tool we are creating here, the OGS editor, and comparing it to like Unity or something like that. But of course it'll take several years before that comparison can happen. Alright, here's the track. Yeah, basically that's how you move the model into the editor. Okay, that's good for now. Let's create other models, I guess. Or no. Or actually yes, why not? Let's create all models beforehand. I'm not sure about everyone doing open, but yeah. Alright, so we need the cleaner and the cleaner base, two more models. Well, except for the ball, but the ball is pretty simple. It's just a ball. So, but no, actually ball is not that simple. It should be of correct size. Yeah, and that size is 30 centimeters, 1, 2, 3 in radius. Yeah, like that. That's the ball we need. So let's have it. Alright, it's UV sphere. And size, radius, rings. Oh yeah, size is 60 centimeters, which is nope. Okay, let me. Okay, now it's size is diameter or radius. Yeah, size is radius, not diameter. All right. So yeah, that looks like it fits the track, and it fits it precisely. Yeah, that's fine. Ball on the track. Ah, not exactly, but yeah, that'll do, I think. So, with the ball on the track and the segments, I think maybe too much. Too much segments, I think. Or not too much. Nah, I think okay. It will do. So let's smooth it. As you can see, it's pretty it's too cubical for me, even for me. Yeah, right. Let's make it less cubical and smooth the faces. Yeah, that's better. You can still see something is not perfect, but it's way better. Yeah, it looks like a dirty ball. Yeah, maybe we should call it dirty ball, not a rolling ball. Why not? Except for there's nothing to create a dirt yet in the editor, but okay, let it be rolling ball for now. Yeah, so the rolling ball, yeah, let's call it the base ball. Yeah, like a baseball. Then we duplicate it, move it to the another layer, call it low poly ball, and that will look fine in the editor, so we'll leave it as is. Also, don't forget to unpack UV unpack to have correct texturing and correct lighting and correct everything. We will also create the high poly ball. Of course, it should be more segments, let's say twice more and twice more, and why not even more, twice, yeah, and here too. Okay, that looks already smooth, and now we smooth it even more. Yeah, smooth faces, and now that's smooth ball. Another great name for a game. Smooth ball. Call it high poly. High poly ball. Alright. Okay. It's been 1 hour and I'm still creating models. Okay, we need to hurry up. Now, we need two more models. It's the cleaner and the cleaner base. So the cleaner is a thing that takes the ball off the track. And to take the ball, okay. So the cleaner to take the ball. Yeah, we'll do it the same way as we did it before. It should be a cylinder with some hole to take the ball. That sounds logical. That can be a big cylinder or a small cylinder. Yeah. So let's make it let's make it bigger than the track, because yeah, it should be bigger. That's the cleaner, not just something else, some small thing. That's a big, large cleaner. Big and large. 1, 2, 3, 4. Yeah. So 1 meter should be fine for a cleaner. Alright, we take what? We take circle. Because there's no better shape than a circle. Except for a cube, of course. Cube is better. So we take... Yeah, that's a pretty big cylinder. Alright. Yeah, I think that's a fine cylinder. Let's extrude it a little bit. Let's extrude it some more. So the ball will be taken by the big thing. And now extrude even more. Okay, I extrude a little bit just for better texturing, I guess, because it's not perfect with the shapes, with the shape I want to create, which is cleaner, as you already heard. Alright, move it here a little bit. Now extrude it once again. and extrude even more, I guess. So the track will be what size? So current size is what, 60 centimeters in height. 60 and then another 60 and then another. Alright. For now let's make the part of the cleaner that actually takes the ball. And then make the cleaner larger. Alright, by 6 I guess. That'll do. So, okay, the cleaner, nobody will ever see the, no, actually, why nobody will see? Anybody can see it, so let's make the bottom. Alright, that's the cleaner for now. And that part specifically is to make, I'm not sure how it's called, but something that takes the ball in. Not sure how to name it, but it should be pretty big. Alright, guess that might be enough. And that's a big thing, not too big. Alright, let's make it smaller. Alright, no, that's big too. Alright, once again, let's make it smaller. Yeah, that looks better, I guess. So we extrude. I guess we extrude. Yeah, extrude. Yeah. Yeah, that's fine, I guess. Okay, make it even more prettier by changing it from cube to something like, you know, like this maybe, or something else, something not standard. Alright, let's move it down to, oh yeah, that, oh no, that doesn't look good, that looks weird. Alright, let's move it up. Yeah, okay. Now, let's make it flat. Alright, S, X, yeah. Now it's flat. Oh yeah, that's almost like Darth Vader taking the balls. But it is actually a cleaner. Nothing to do with the main character. Although this can be made into some interesting battery, I guess. Someday maybe. But not today. That's pretty flat, as you can see it. So what do we do? What do we do? We make the hole. Alright, how big is that? That's 1 meter in size, in height, and something like, and big enough in width. so should be enough. Though. Alright, extrude. Make something like a good hole. Minus, nope. 2. Yep. Make it deeper. Yep, 2 dip. Yeah, that, no, wait, that's not, yeah, that's too deep. Alright. Okay, that's deep enough. And that looks like a standard hole. Yeah, looks like a good hole. Alright. So that's the cleaner basically, and that's actually the base cleaner. Base cleaner, yeah, right. Now, wait. Okay, that's weird. What the face is doing here, I'm not sure. So, yeah. Or, no, wait. Yeah. Yeah, that's fine, okay. No, it's not fine still. Remove the face, but select the vertices. Yep. Alright, we extrude, we make something. We extrude again. Make it more natural, let's say that, so that the border is not the border is actually real of the real width. Otherwise it might introduce some glitches later, and we don't want glitches. We want a good cleaner, yeah, without glitches. That's what we want. So what to do with everything else? What to do with everything else? I think we can smooth it for simplicity. Yeah, why not? It should be smooth. It will be smooth. Okay, smooth here. I mean, not smooth, but select these faces and these faces, and except for up and top and bottom. We also have these faces. Alright, let's I guess select these two. Okay, this alright. You will be smooth too. Alright. So except for I didn't want the inside. Yeah, that should not be smooth. Yeah, now wait. That's a base model, so it should not be smoothed, right? Let's rather copy it and smooth it. Smooth it once we call it the low poly cleaner. Yeah, that's better. And now make the high poly cleaner. Call it alright, we are half through the estimated time. That's a little bit, the modeling takes a little bit longer than I thought. Yeah, that's already took me an hour. Half an hour to create an empty project, 1 hour to create models, and we are going good. So okay, that's the cleaner. That's the wait. Alright, somebody else has been named wrongly, so that's the base cleaner actually, and that is the low cleaner. Low poly cleaner. Let's make it low poly. Alright, we want it to smooth. Let's smooth it. Alright. Yeah. Well, not as smooth as it could be, but smooth enough, I think. After all, we're not making some cool games. We're just making a rolling ball. Yeah. So why shouldn't it be? Should it be some cool cleaner? It should be some standard cleaner. Yeah, you can see in everyday life. And that's a pretty standard cleaner. Yeah. Yeah. Okay, we don't need hot poly model for now. We will make the low poly model the same as the high poly model for simplicity reasons. So now we need the modifier to smooth a little bit, but we want to restrict it. Yeah, we want to smooth the edges everywhere, especially for cubical shapes, to make them look better. Otherwise they don't look nice enough. Okay, now we duplicate it, and let's name the copy as high poly model. High poly cleaner. Now let's go back to the low poly cleaner and apply the modifier so that it looks better, I guess. Yeah, it looks good enough. So once again we need to smooth a lot of things. But now we will select those parts that needs to be smoothed because there is less to select than before. Okay, let's try something to mass select things. Yep. Alright. Yeah. Mass selection has some downsides. Okay, you don't want it. I can select you like that then. Wait a second. Wait a second. Let it be like that. Okay, select. Looks like I took bevel as it is, and it produced some large, let's say edge, like thick edge. Yeah, too thick for me, but let it be that way. Thick edge may be good enough. Alright, I'm still selecting one by one. Yeah, very productive, as always. Okay. Yeah, also select here, and that edge, and that one, and that, that one, then that one, that one. Alright, that looks like the only thing we need to smooth. Yeah, that looks like the only thing we need to smooth. Bam. Yeah, that looks better. In a way. Yeah, in a way that looks better. Although I would also smooth these things because they're quite strange. Yeah, why not? Alright, let's smooth them too. Yep. Well, Okay, that'll do. So this is our low poly model. Yeah, that's our low poly model. We have smoothed it a little bit. Alright, let's create the UV map. And that's basically it. Okay, high poly model we need probably to smooth here too. Yep. And here too. No, wait. Here exactly. And here exactly. Yep. Yeah. But as always, we increase the number of segments for bevel. Oh yeah, that was much better. Smooth means good. Yeah. That's high poly cleaner, that's the low poly cleaner. As you can see, it's a little bit uglier, but it has less polygons, so the game will run faster, even on old machines. Now that we have the cleaner, we need the cleaner base. So the cleaner base comes, I think, comes cheap. We'll just select the inner circle of that thing, and the inner circle is like this. Alright. Or like this. Alright, that's not sure. Alright. Okay. Select the inner vertices. Okay. One by one. Oops. One by one. Okay. Alright. Now we what? Now we do duplicate it. Move it away a little bit. And separate by selection. And then we have two models. Move that circle to the new layer. And now make the what? Make the cleaner base now. Alright. And the cleaner base will be just a cylinder. What else? We extrude it by, let's say, 10. Or even more. 5 more. Yeah, why not? Yeah, looks like a good cylinder to me. Yeah, pretty good cylinder. Now we need to smooth it again, because yeah, smooth is good for now. Yeah, that's wait. Yeah, as always. Alright. Now, since this is a base cleaner base, we duplicate it, move it to the next layer, and code low poly. Low poly cleaner base. Alright. We also do unpack UV map for correct texturing. And now we alright. Okay, what is that size? I'm interested. Yeah, I wonder what size is it. Looks like 09. Yeah, that looks like 09. So let's create, since we create a high poly model, let's create some new cylinder with many vertices and many vertices. just many vertices is enough. Yeah, many vertices is good, at least for modeling. Alright. The radius is 0.45, and that should be the same size. Not exactly. It's 1 and 8. Alright. Oh, god damn it. Alright, just its radius, right? Not diameter. Oh yeah, no, that should be exactly the same radius. Yeah, looks like exactly the same radius. Yep. Vertices. Yeah, I think it's enough. Now again, smooth it. Now that's even a better cylinder now. Move it up and a little bit, make it a little bit taller, a little like as much as 10 and 5, that's 15 meters. Be it 15, yeah. Yeah. That's our high poly cleaner base. Okay, looks like we have all the models we need for the game finally. Oh man, that took some time, and that took even more time when I first created it for the first time. Hopefully today is not the first time. Yeah. Alright. So what we need now is to export 3 new models. By the way, yeah. All of them have UV maps, so we can, I guess, export them. Okay, let's export the ball. Export ball. And then export the cleaner. Now export the cleaner base. Cleaner base. Alright. Use them in the editor. We just launch it, and it already knows, since we saved it in the models directory of the new project. Yeah, it's the rolling ball.ogs models directory, and since there are new models, the editor already knows there are new models. Yeah, models are good. Let's add them. Oh no, wait. Yeah. So we add what? Ball? Okay, ball. Select the ball model. Yeah. Move it up a little bit, like 1 meter up. Okay, let's save the camera position for future reference. Yeah, the ball does not look really nice. Yeah, it looks pretty ugly. Because we have no textures yet, but I think we will create it in a minute. And textures are simpler to create, at least for a game like that. A ball and a few models. Alright, let's add more models, and we need cleaner. And let's select the cleaner model. Oh yeah, that's a big one. Oh yeah. A big cleaner, oh my god. I think that cleaner can take not only the ball but the whole track inside it. Okay. the track should be strong. Alright, -1, move it away a little bit, move it even more away. Yeah, that's okay, but actually I did a little bit wrong. First we need cleaner base, because cleaner will be attached to cleaner base. Yeah, so cleaner base. We added the node, selected the cleaner base model, and now position the cleaner base model. It's -5. Yeah, that looks like a cylinder, So we move the. Yep, cleaner is now the child. As you can see, it fits precisely because yeah, that has been modeled that way. Alright, what? Alright, save, quit, run again. Alright, I forgot to save the new camera position. Alright, let's look like that. Or not like that. Okay, it's good enough. Then we sync camera to node, save it, quit it. Yep. Okay, so now we have the models. Yep. Okay, we don't need Blender for now. No, we do need Blender for now. So we have models, but they don't have textures. Yeah, that's why they look that ugly. Because that's the default texture called noise, and as you can see, that's a pretty good noise. Yeah, a good noise. Okay, here's the music. And the music has finished, and we run it again. So, okay. Now create. No. Now to display. Let's say, material or texture, but the correct term is material, and material in our case contains two obligatory textures. One is diffuse one, which is just let's say color, and the second one is normal map, normal, which says where the bumps are, and the bumps, not only the bumps, but overall shape, where the edges are, for the lighting to be correct. Here there is no normal map, so yeah, it's pretty ugly. So how do we do the normal map? The normal maps are easy to create with Blender. So you select the low poly model. No, first select the high poly model, right? No, wait. First select low poly model. Yeah, right. Select all vertices, and you create a texture. So this is a plain normal map, so call it plain normal map. Okay, it's 1024 pixels in size, both height and width. That's pretty enough for us, for now at least. And we do the same for all models. We select all vertices, we add, since this is a catch, we call it catch normal map. Now goes the ball. That's the ball normal map. For now they are blank and therefore dark. Nothing is yet rendered, but yeah, soon we'll change it. So cleaner gets its own normal map. Alright, and now cleaner base. Okay, good. Now all 5 models, the plane, the catch, the ball, the cleaner base, have normal maps assigned to them. And now we can bake the normal map by taking the difference between the high poly model and the low poly model and putting that difference into normal map texture. Yeah. And that's basically the technique behind it. Okay, here's the bake. We want to render normals from selected to active and in tangent space. That means it's view independent. There are other spaces that are view dependent, but we want independent. Yeah. Why depend on anything when we can depend on nothing? No, actually, that's just what we need. Okay, so bake it. So we selected the high poly model, the low poly model, displayed them at the same time, and selected normals as the bake mode, and selected tangent as the normal space, and selected to active checkbox. Now bake. Yep, that's the normal map. We save it. Okay, we go to pipeline textures and call it that's plain normal map, so call it plain N for normal. Done. Next. Catch. The catch part. So select the high poly model, select the low poly model, and the bake. Alright, select save the image. Since this is catch, we call it catch N for normal. Now again for the ball. Select the high poly ball, select the low poly ball, and bake. Save the image. Call it ball N. And you probably know what N stands for. Alright. Low poly model, high poly model. Okay, select high. No, wait. First, low poly, display its normal map, in its texture, which is normal map. Alright. Select the high poly model, select the low poly model, and bake again. Yeah, that's very interesting too. Save the image again, call it cleaner N. Now, the last model is cleaner base. Select the high poly model, select the low poly model, and bake. Save the image. Cleaner base and cleaner base. Alright, let's call it like that. Okay. So we have the normal maps, and yeah, Blender, we can shut it down for now. So normal maps are in place, and that place is called pipeline textures. Now let's remove some log files. The log files have been created by the OSG exporter. They contain some information. Yep. Some some information, yeah, that we don't need. So we remove all log files. We only need OSGT files. Okay, so you can see we have many new things in our Git repository. So let's commit them all. First, let's add them all, and now commit it. So what have we done so far? We have the scene. Let's have scene, models, textures. That's a good name. That's basically all we have. And by the way, textures, only normal map textures. We need more textures actually. Yeah, we need more textures. So let's create more textures, and for simplicity reasons we will only create simple textures. Simple meaning just a color with a little bit of dirt. Okay, wait a second. Let me restart the jump. Okay. So create a new file. No, that's too big for us. Since we want some simple texture, let's have it like yeah, 256 sounds like a good one, like a good size for a dumb texture. Yeah. God damn it. Okay, let's repeat. Alright. That's a good texture. So what we do? Simply, so first we will create the texture for, let's say, track. So track should be probably made out of metal. And so we need some metal color. And what I use is I guess that thing. No, no, not that thing. Okay, how do I do it? Color balance. No, that one. Yeah. So I use color and colorize. I think some gray, something like that. Looks like a metal, or that. Of course, metal can be okay, that looks like a metal to me. Let's hope it looks like a metal to you. Now let's add some dirt. Select some non-standard brush. Increase its size, like 200. Yeah, that's a good brush. And add... no, wait. That's too much dirt for us. Let's change its opacity to like 10%. No, that's a good dirt. More like a web. Alright. Okay. Yeah, too much dirt. Too dirty. And we are making a clean game, after all. Yeah, that looks better. Like a real dirt. So we export it as let's go to the rolling ball. pipeline textures and call it the since this is a track part, we call it track text. Track text for texture. Export it. Okay, let's check it out. No, not check it out, but first, now to we have track texture. We have normal map for both the catch part and the plane part. So we can have materials. Now we go to default compositor and create, let's say, material. Yeah, we create material, and okay. Can't remember what to write actually. Not so easy to remember. Okay, we material, main, plane, diffuse, normal. Yeah. Material, main, plane, diffuse, normal. Right. So far, yeah, materials are written by hand to main, plane, diffuse, normal, and here goes the path relative to current directory. Directory relative to the project directory, rollingboat.ogs, as we called it. That's pipeline, textures, and track text png. That's the relative path for diffuse texture, which again is just a color texture, and the second texture we need is the normal map, and its name is plane N for plane modal. Yeah, and we call material plane like a modal for, yeah, because it's simpler. And we also have now catch modal. It will use the same diffuse map texture but different normal map. Alright, material main plane, yeah. Material main plane. Now let's select the plane. Select material, and we have the plane. Now select the catch and material and catch. Now it should look better. Yeah, looks like the dirty metal to me, or somewhat dirty. Yeah, not much brighter than it was. That is good enough for us, I think. Although that looks a little bit too much like the previous game. So let's brighten up a little bit by adding white dirt. Yeah, why not? And rechecked. Wow. Now that's too visible now. Okay, let's add some color. Red maybe. Blood on the track. Yeah, that's another game. Okay. No, actually that's not good enough. Let's colorize it a little bit more. Well, let's add some dirt. Some more dirt. Oh yeah, that looks like good dirt. Ah, and very dark track. Really like some blood or something. Okay, let it be that way. We can call it blood bowl, not rolling ball. Anyway. So, we need to, now we need texture for the ball. Let's take that and make it something like yeah, that looks oh, yeah, that looks fine. We export it as ball texture, ball text. Now add it to default compositor by hand again. Okay. Ball texture, ball and texture, and here's the ball, here's the texture. That's a pretty bright ball in that dark track, like a gold ball. Yeah, that's a good name too. That's a pretty dark track. Yeah, that's a good ball. But I don't like the track. Okay, let's have that. Not as beautiful as the blood track, but yeah. Now we have two more models without textures. Let's use the same texture again and colorize it even more. I think enough black. Maybe something pink or something red. No, too light. Okay, I like to use the same color for everything. Okay, export as cleaner texture. Now use it. Default composer, yeah, we want it for the cleaner. So cleaner, diffuse is okay. That's already 2 hours of the live session. A little bit too much for the a little bit too much for the putting models into the editor. Yeah, that's something to work. Yeah, for us, something to work on, because yeah, that's a little bit too long. Now assign material. Oh yeah, that's not as bright as I thought. Not as bright as I thought. Alright, let's colorize it again. Maybe. Alright, let's make it blue. Good enough. Okay. Well, at least something. Now it looks like the track. Yep, not suitable too. Okay, let's recheck. Oh, everything is pretty dark here, yet. But it's brighter on that side. Okay, that'll do. That will do. I think we will use the same material for... Yep. And now we almost have the scene. Yep, that looks strange. Okay, that looks too dark. The cleaner looks too dark. And I think I need to change the model a little bit. I suspect something is a little bit wrong here. In here, yeah, it's too dark. So what we do is recalculate the normals. Normals recalculate outside. Yeah, now it's brighter. And now we need to redo the normal map. Okay, and oh, here it's wrong too. Okay, recalculate outside. So select the high polymodal, select the low polymodal. Select both and then bake. Re-export the model. It's called cleaner. Now resave the normal map. It's called cleaner N. Yeah, that's correct. Let's recheck. Yeah, that is brighter. That's a good cleaner. Okay, we don't need Blender anymore for now. Now finally let's build the track. So how we are going to build it? So we have all 5 models and we need to build the track. Hey there. So let's, I guess, yeah, let's make it a child. Yeah, it's going good. And it's a live session now, explaining how to create a game from scratch. Yeah. So for now, we have what? We have modals. Lots of modals. Actually, 5 modals. And into the track. Yeah, that looks like... that looks good. So I made the catch part child of the plane part, so I can now copy the plane and paste it, and that's plane 1. And I can move it a little bit, let's say down. No, even more down. Yep, move it a little bit here. No, first rotate it, I guess, by 90. Yeah, rotate by 90. And move it, move it, move it. Okay, move by X. Okay, move it up a little bit. Okay, move it closer. No, here. Okay, hope it should match. Oh, not exactly a match. That should match. Okay, looks like a match. A little bit up. No, wait. Or yep. A little bit. Yeah, a little bit more. A little bit more. Okay, looks like the ball can go here. Yeah. Okay. Okay, that's plane 1. And actually we can make it plane 1, plane 1. Alright. Now we need to copy that and paste. Yep. And we need to rotate it too by Z again. Okay, the track is almost, it's almost here. The blue track. Okay, that was a little bit off. track is a little bit off. Okay, we'll fix it later in the model. Now let's create the fourth part. Yeah, there is a lot to make things faster. For example, like snapping objects together, because yeah, fine-tuning them, fine-tuning their coordinates is a little bit too interesting for a live session. I understand that is very interesting, but yeah, that's very repetitive. But for now, yeah. For now, it's the way it is. So we have a complete track. Okay, save it, quit it, relaunch it. Yep, that is almost. So what we need is some parent node. Let's call it track 1, and put everything into here, Yep, that's track number 1. And we create the second track, and then make it a little bit lower, like I don't know, like this. That looks like a track. And the last time it was yeah, now the cleaner looks a little bit too large for that tiny ball. So place the ball to the beginning of the sequence, to the beginning of the track, I mean. From scratch means I teach how to use the editor, and a bit of scripting, for which we have like half an hour left. Yeah, that will be a fast scripting. Alright, move it down. Or no, wait. Since this is a ball that rolls down the track, we will simply assign it to the first track, which is plain, right? Yeah. I can talk. Yeah, can talk right now. Alright, move it. No, move it. Let's say here, that's the beginning. Looks like the beginning. Yeah, looks like the beginning. now we are finally almost ready to make the first script. Modeling is not fast in here. Okay, let's move it somewhere. Okay, that looks that looks like the center. Okay, the cleaner is a bit too big. Maybe too big. No, that's not exactly the center. Okay, let's move it. Okay, that's pretty dark there. Where's the light? Okay, let's move it to another side a little bit. Yeah, almost. Okay, that's better. Okay, that looks like a center. Okay. Okay, make the lighting a little bit easier for modeling. Okay, that doesn't look exactly like a center, but let's check it out. It can catch the ball here. It can catch the ball here, I think. Let's check it out. Yeah. It looks like it can catch the ball everywhere. Okay, where's the light again? Okay, it's there. Now let's move it somewhere like -30. Yeah. Okay, that's a better. Okay, where am I? Okay, it's almost. Yeah, it's not almost. It's 2 hours and a half. And we have the track, the ball, the cleaner, and the cleaner seems to be able to align with all the catch parts. We call it like that. So the ball, the track, the cleaner. Okay. What would be the best view to look at it? Yeah, that's the view. We can select all the tracks. Yeah, we can select all the tracks, so yeah, it's a little bit bigger than I thought, but why not? It's a big cleaner. And big cleaner should be big. Okay, that looks like a good view. Okay. Now, let's make another cleaner base. Let's make a pipe, the incoming pipe, let's call it like that. That's a pipe the ball comes from. We will use the same model as cleaner base. And we will use the material, which is, let's say, cleaner, catch ball. Let's use the same material as the ball. Okay, where are we? Okay, let's move the light a little bit. Okay, where is it? To another place. Okay, let's move it maybe here. Nope. Okay, that's better. Okay, that's better for the lighting. Yeah, that's a big pipe for such a small ball. Well, after all, that's a game of the big pipes. Why not? Why not? Alright, model for the cleaner. Model, yep, same texture as the same texture as the ball again. Let's rotate and move it down, down, rotate it a little bit more, and that is the outgoing pipe. Let's go that way. It's a pipe the ball will be catched by. Alright, let's make it closer and a little bit higher. Alright. Yeah, that is a game of big pipes, really. That's not a rolling ball game. That is for sure. Okay, that looks like a good view. Okay, let's remember the camera position. And now finally the ball. Yeah, we're almost out of time. We have everything static here. The incoming, the outgoing pipe. Yeah, outgoing pipe. Okay, that took almost 2 hours and 40 minutes to model and to place it in the editor. Yeah, that takes a lot of time, really. Now, finally, yeah, I think now finally we can start the scripting. Alright, we need to script the ball. We need to script the cleaner. So the ball rolls down, 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 and ends up here. The cleaner can take this, can take this, can take this, can take this, this. Yeah. Yeah, that's a lot of work left. All the scripting. Alright, so the ball comes from here. That we can skip that animation. But now we need to make the ball roll down. Alright. So make okay. We actually only made oh my god. Huh. The scripting, I hope scripting will go faster than modeling, because there's a lot to do. Alright. Let's check it out how it looks like in the player. Yeah, that looks the same. So the ball needs to come down. And the first thing we need is the main script. Alright, let's commit what we have done so far, and that is what? A complete static scene. A complete static scene. Now all we have left to do is script it, yeah. Easy. Easy, easy. Alright. Let's have a look how it have been scripted before. So we have what? Script create, script destroy. And we have main class. Let's create it. So, since we assign a script to a node, it knows the scene name and the node name, and we need that for the script to act upon that node. In our case, the main script will simply serve as the starting point of the game. Okay. I make some basic script main to just check out that everything works as expected. Yeah, let's compare it to what. Alright, let's import everything. So script create, node name, and environment, yeah. So each script is passed scene name, node name, to which it's attached, and the environment. And environment is a special, let's say, environment in which all scripts and parts of the engine communicate. So that's basically the main queue, let's say, or alright. Looks like it's a little bit incorrect. Oh, let's try to assign the script again. Alright. Let's have a look how the old script looks like. Oh, that's a big script. So we do init, then we do dinit, then we do script create. Alright. Script destroy doesn't have that, and doesn't have self. Correct. Okay. Light script main. Well, yeah, we assign the main script to the light because that's the node that will stay no matter what happens. So yeah, that's a good place for the script. So let's run it. and we can see that main has been created. So the script is initialized and the main destroyed. So the main is deallocated. That's good. So the first thing we need is the bool API, and the bool API is what? Yeah, what is the bool API? The bool API is a script that can register certain actions into environment, like move down. Alright, so bool API. Well, before we go with the bool API, we first need to need to write down what to say to the bool, and then we can come up with the API. So okay, let's listen to the let's listen to the space key press. Yeah. That will be our signal to start the game. And to listen to that, first we need to create the environment client. Let's call it C. Environment client. It takes environment and the name is main. Then we do self C clear, that tears down all the necessary things, and then we deallocate it, which is destroy. Self C environment. Oh, let's check that it's correct at all. Yeah, that's correct. Nothing has crashed, and that means the script so far is correct. Now we need to listen to what? To space key press. That's input as space. Okay, I can't remember what is it exactly. Let's see what it is. Input space key, right? It's input space key. We listen to the 1 value. Yeah, input space key is the key we would like to listen to. In environment, everything that comes through environment comes in, let's call it messages, and each message has a key and a value. In our case, when we press the space key, it generates the 1 value, which means it's pressed, and when it's released, it generates 0 value, which means it's released. So we need a listener to listen to it. We will create main impl implementation to listen to things, to subscribe, to be the subscriber. And in that class we definitely want to manipulate the environment, and we can only do that through the environment client. So we listen to input space key by assigning the method of the main impulse. So since we assigned, we need the impulse. So let's say impl on space or on game start will be called, and let's create that method on game start self key value. Yeah, that's the signature, the standard signature of the environment method, and we will see what it reports. Start key value. Alright, we have 7 minutes left. Basically, obviously that's not enough to make the game 3 hours, yeah. But we'll try to make it faster now. So main has been created. And we need to check if space is detected. As you can see, I press the space and it's printed. So as you can see, what is reported is an array of strings named input space key, which is the key, and an array of 1, the value, in that case 1. So yeah, different keys can have different values, and in some cases there are multiple values for one key. For example, like a list of items. So in this case, since we listen to key press, there's only one value, which denotes if it's pressed or if it has been released. So on game start, we want to do what? We want to tell the ball that it needs to move. It really needs to move because it's already almost 3 hours and it really needs to move. So we call self C set and we call the ball. Let's say we can call it like the ball is the type, the scene in the scene, and the name of the ball is, let's say, the ball, and these values will be unwrapped in a minute. So ball, scene, ball, moving to 1. So that's the API we want to create for a ball. For that ball, it will be type ball scene. The scene we will tell it, and the ball name. Yeah, the ball we will tell it to, and its property is moving. And we set it to 1, so it should move when we set it to 1. So okay, let's have some constants like ball name. Yeah, it's basically the ball, right? Yeah, it's really the ball. So, since we since the main script has been assigned to the light node, it has the scene name passed in, and so it knows what scene name to reference to. And let's set it as a const. So the scene const will have the value of scene name, which is passed to the script, which is later used in this on-game start scene with the $sign. Now we also need the ball constant, and since we know the ball from the constant, main ball name, and let's press space. So yeah, the environment says ball default ball moving. No such key has been registered in environment, which means no provider for that key has been registered, which means no ball API exists yet, and we definitely need to create it. So let's copy the main into the ball and edit. So the ball API, yeah. Since this is a ball, we call it ball impl. In that case, it doesn't have on game start. It might have something else, but in a minute. So there's the ball created, and we don't care about it now. So since this is an environment client for the ball to provide ball API, it's called, this environment client is called ball. And now we instantiate ball impl. We don't listen to space key. We probably have that left because the same scene. We need the scene. Yeah, we do the same here. Script create. Yeah, we create the ball. We destroy the same way. Yeah, that's the basic ball API, and we need to assign it to the ball. Okay, the ball. Select the script. Ball. Save. Quit. Okay, let's press space. As you can see, there's yet no ball API, but we are really close to that, and let's provide it. And we also can set not only the scene but also the ball, I think. Yeah, right. Because the ball constant is the node name, is the name of the node. We assign the script to. So yeah, we know the scene and the node. And let's provide the key. We also have the type, by the way, the ball type. I think this can be referenced to. So let's call it type. Ball, I guess. Yeah. So type scene ball. Actually, the type equals to the ball name, and that's the ball. So yeah, then we don't need another constant actually. So yeah, ball, scene, ball, moving. And now we need to provide the setter and the getter. We might provide setter and the getter for that key. That means we will be able to either get the value of that property or set the value. And we want to set the value, but we don't want to get the value, we only want to set the value. So self-impl, let's say set moving will be called. So ball scene ball means type, group, item, and property. That means that when we call moving property of the ball in that scene, which is of that type, we will call that method, and that method is set moving self key value, and yeah, that's it. So now it should not say no provider for key ball default ball moving because it should be registered. Let's check it out. Yep, right. Instead of saying no provider, it calls the method set moving with the following parameters: ball default ball moving 1. Alright, so now we have the API call for the ball, but it does nothing. Whereas we want it to move. So how do we move there? That's the question we're going to answer now. As you might remember, 3 hours ago, or yeah, actually that's 3 hours, we are live. Actually, originally we advertised this as a live session in which we make a game, a complete small game in 3 hours, but yeah, there is a lot to do for the editor to make it really a game of that size to fit into 3 hours. We will definitely address it in the next release, so yeah, hopefully the first stage of modeling and creating an empty project will take less time, significantly less time than 1.5 hours, really. Or actually 2.5 hours. Alright. That's 3 hours. So, we want to move the ball when it accepts the moving property set to 1. So what do? We do the action. There is default actions file, and an action is a sequence of points, let's say points, that in case of let's say rotation and position, that a node should pass through. That is, we want to tell the ball to go from let's say position 0, 0 to position 1, 1, and that means 2 points. Yeah, that means 2 points. So there are different types of actions, and to move, to change position, we need the move action, type move, group default, and item, well, let's say m move ball, and the property. So we only need point. The first point is starting point, and it's 0. The second point is let's say it will take about a second, and it will move to let's say 1 meter by x. Yeah, that is good enough. So the first point is at 0 second, we are at 0, 0, 0, and at 1 second, which is 1000 milliseconds, we are at 0.100. And since we're not relative, that is, there is no that property set as such, by default relative is 1, and that means that we take the difference and make the delta, and so that means that to move by x by 1 unit, which is 1 meter, and to do it in 1 second, which is 1000 milliseconds. Right. We also need to rotate it, we also need to do other things, but for now, yeah, that will do. That's the action, which means move the ball by 1 unit in 1 second. Yeah, by x-axis. Well, let's do it. So we need the ball script. So ball, let's say action. Move default m move ball. That's the name. And we want to start the action so that the ball is moved. So we do it by the following. Let's say we also need the const. Let's call it move, and yep, the move constant has the ball action value, which is this move default m move value. So we do move, then we provide the scene, then we provide the node, which is the ball, and then we provide the active, and set it to 1. So basically what we said is that move default m move ball, this is this constant, and then it acts upon the ball in that scene, and we set its state to active by assigning the value of 1, and that should be enough to move the ball. Let's see. Oh, yep, it did move once I pressed the space key. Let's check it once again. Yep, that's moving. Alright. Of course we need to move to the other side because this is the minus direction, negative direction. Yeah. So instead of moving to the one side, we move it to another one. Yeah, it moves good enough. So really this is a rolling ball game, so it actually cannot move like that, though it would be funny, but not very realistic. So it needs to go like directly, then down this angle, then on that flat surface, then on that, and then here. So that's like forward, a little bit down, forward, a little bit down, and forward again. So this will be at least 5 actions. Forward, a little bit down, forward, a little bit down, so a little bit down now. Now wait, first let's make the forward. So we need to move the ball forward, but only by this amount, and initially the ball is in what position? The ball is in this position, and that's about, let's say, I don't know, that's definitely not 0. Alright, let's take Blender now and see how many units is the track model, one of the track parts. Okay. Alright. So let's see the ball. Let's move it a little bit. Okay, the ball looks like this. Yeah, that's a ball. Okay, so it's here and it goes 1, 1, 1, 1, 1, which is 0.5. So after going 0.5, it should go like this. What that means is that we change the 1 meter to half a meter, and check it out. Alright, it's hard to check that far away, so yeah, let's remember our position here. And the camera is a little bit not friendly. Alright, that is better. And let's see. Yeah, actually, while we do this, the cleaner and the cleaner base can wait somewhere else, like here. Yep. Yep. It can really wait. So yeah. Let's move the ball. Yep, that's correct. Ah, god damn it. Wait a second. Wait a second. return to the initial position. First, let's save the camera position, and then save the scene. Restart the editor. Yep. So, yep, that's basically the forward motion. And now we need to slide down or roll down a little bit. So how little of that bit? That's the question. That's 05, 1, 1, 1, 1, 1. And that is that's bigger, and that's 2 meters. That's 2 meters, and 02 meters in height, 2 meters in length, and 02 meters in height. So yeah, so far we have seen the simple action to move the ball in, let's say, actually the move action can have more points, and why not move the ball down by adding another point? Yeah, right. So yeah, it's hard to say how much time. Let's say 3 seconds, and we need to go at 2 meters more, and 02 meters down. That's about it. Let's see. Almost. Oh yeah, right. I forgot that that's a relative specification. So minus 2.5 minus 5 is actually, yeah, that's 2. Since we use relative values, yep. Actually, yeah, as a feature, this ball can skip rolling and just slide down, although that is not very interesting. So now the question is, like, how much time do we need to move down that path? And the answer is, I don't know, but of course I can calculate it. And all I need, since we move half a meter by half a second, no wait, we move half a meter by 1 second, that means that we need that length, and we can find out just how long it should take. If you want to make it if we want to make it consistent, and we do want to make it real, yeah, make it look real. Okay, we don't need the browser for now, I guess. Okay. So we take that length and that height, and we get that length. So that's 2 meters, and that's 02. Okay. Let's see. 2 meters by 2 meters plus 02 by 02. We get 404. And we take the square root of that. And that is... we can't take square root of that. Okay. Alright, we need to take square root of that, and that is... let's use anything to take square root. Okay, where is it? Square root. Okay, I can find this. Just how do you take square root? Okay, that's good. GNOME calc or something like that. Good help. It's something like that. 201. 201. Okay. It's 201, meaning its length is 201. Alright, its length is 201. 201. Yeah, that will be moved without acceleration because, yeah, acceleration is too much for me. Yeah, because action currently, that action does not change speed dynamically, although that is something to keep in mind for later. So the length is 201, and since we move 05 in 1 second, we move 201 in x seconds, I guess. So that gives us what? 402. That gives us 4 seconds. Alright, 4-2 then. 4 seconds and 2 and 200 milliseconds. Alright, let's check it out if it looks, although it will look as ugly. Well, yeah, I guess that is correct. I guess that is correct. Now we need to move forward that length, and that means okay, and that is and that means 3339. Okay. Okay, we are closer to finishing the first part of the track. And now we need to move, yeah, a little bit like this. And like that, a little bit lower. Okay, let's remember the camera position, save it, restart it, and go. And that's almost it. Okay, that's not it actually. Alright, 2 and 5. It moved a little bit longer. Okay, we move then forward, then a little bit down. Okay, something is not right. Yeah. Let's see how it goes. Yeah, it's definitely not right. Although it should be right, because the length is the same here, right? The length is the same, but they move differently. That is strange. Okay, let's see without it once again. That is strange, really. Let's move first. Okay, it seems to move correctly here, and then another forward, and then it goes wrong. That is strange. Because its length is not 2.5. Okay, again. That tricked me. It's 5, 4. Right. Yeah, relative values are not as obvious. But okay. Okay, a little bit down, then forward, then a little bit down. And stop. Right. Okay, now just a little bit forward, which means a little bit forward. So how a little bit is that exactly? That exactly. That's about what? 04. That's about 04. Okay, let's do this. We need 04 more. 04 more, that's 5.8 at the same height. So 04, 04. So again, 05 for 1 second and 04 for x. That gives us 08, 08, right. That's 800 milliseconds, and it should be all set. Okay, we are 30 minutes. More than planned. Okay, and we slide the ball down one track. Now, yeah, that was single action to slide down, slide down, slide down. Now we need to rotate it at the same time, and to do that, we do what? Obviously, we create a new action. Okay, this is the second time the music has finished. That means it really takes longer than anticipated. So, air move ball. Let's go like that. Oh no, move down and rotate down. Yeah, roll down. Yeah, that's better. So the first point is 0, 2, and the second point is obviously it takes 1 second, and now we need to find out like how fast to rotate. That's not easy. So for now, just take 45 degrees and check it out. Okay, change the referenced action. We call it now move down. Alright, first check that move down works. Yeah, move down works. And now we need another action, which is move, and another. No, wait. We need not to reference another action. We just need to create a new action. This is a move action. This is a rotate action, and to run the same both actions at the same time, we need a so-called spawn action, and we'll call it roll. Roll. No, wait. Yeah, roll down. So what it should do, what it does actually. Yeah, the spawn action launches several actions at once and finishes once all actions has finished. So let's reference first the move down of type move, and the second one type rotate down. There is a little bit of redundancy here, as you can see, rotate and rotate, but yeah, for now that has to be done. Alright. Yeah, so spawn action called roll down has two children, move down and rotate down, which both should result in the rolling ball down, in a ball rolling down. So spawn default roll down. Yeah, that's all the change, and check it out. Okay, nothing is rotated. That's good. Has less than 2 required points. Alright. Why does it do that? I'm not sure. Okay, that's strange. Let's check the old. Ah, that is my error. Yeah, too many degrees. 4 instead of 3. Alright, let's try again. Yep. Okay, I think I know what to change here. We can skip rotation actually while it slides down. Yeah, why not? Let's skip it. Let's just rotate only on flat surface. That will make it easier for rotation, animation, and let's check it out. Well, almost. Right. We use relative again and again. Okay. Yeah, instead of just rotating. Okay, that looks a little bit better. A little. But instead of, yep, like this and like this. So when it, okay, thank you. That's not yet as great as planned. Yeah, but it takes a little bit longer. Yeah, that is slow on rotation. Yeah, that is really like a Okay, so this is just animation, no physics. Otherwise I wouldn't be guessing the degrees to rotate by. It would work out of the box, and someday it definitely will, but yeah, physics is not an easy thing to implement, even a ready SDK like a bullet, but definitely one day we'll have it here, though not today. So it's 4 and 2, and it's 4 and 2, it's should be like that. Yep, let's see. Yeah, looks like it slides down, then that's an interesting animation, I guess. Okay, let's let it slide. And here we just 94.1, 94.1 second, and how many degrees for, no wait, for 1 second it's 90 degrees, and for 1/8 it's x, so that gives us, alright, that's weird. Ah, right. Okay, that's better. Okay. Let's check it out. Slide down. Roll forward. Slide down. Why not? It's a rolling sliding ball then. Okay, looks like it should rotate faster first. Let's go. Let's say 180. No, that's too fast. Let's go at 135. Yeah, that's good. 135. That still stays. We increase it by 45. All right. 45 is 97. Let's go. Slide down. Move. Slide. And roll again. Yeah, why not? Why not, really? Why not? So we take 0.8 seconds and we rotate by what? Okay. And how many by 8? .405. Alright. Move. Oh, God. Okay, looks like too many spaces. Oh, really? Wow. Too many spaces, I can't believe it. Looks like we found the bug. Yeah, really. Wow. Okay. Okay, let's plan for another revision. So, how to call that bug? It's a bug in actions. Parsing 0 space 0 0 0. Rotation results in invalid point. Yeah. That's not pretty. Yeah, point parsing bug. Disgusting. But okay. let's leave no spaces except for necessary ones, so we get like, yep. Okay, nope. Nope. Ah. Wait. Oh, we need another that. Okay, slide down, roll down, slide. Ah. Yeah, alright. Okay, let's go. Okay. Ah, what do you do? Wait. Okay. But that should really be like that. Ah, god damn it, yeah. Animations are hard. Oh, wait. Okay. Let's go again. I think we need to simplify the rest of the workflow and the rest of this live session, otherwise it's gonna take like the whole day. Yeah, 3 hours and 45 minutes, and we still only get to one ball. Rolling and sliding only down the first track part. That's a little bit too much. That's a little bit too much. So, yep. So now what? So now the ball moves down, and since the ball has finished, we need to report that we finished moving. Yeah. So what do we do? First, we subscribe to what? We listen to the move, scene, ball, active change, and we only want the 0 state. And we'll call it like on stopped. So when the move action stops, we get the notification into here, on stopped. Self key value, on stopped, key value. Alright, let's check it out. So we started the ball, it started to move and slide and whatever. Yeah, that looks weird. And on stopped. Yeah, we did receive it. Yep. So we can remove that, not remove, but report that we have stopped. The ball have stopped. So let's report it. Ball, scene, ball, moving. Yeah, stopped. And now listen to the stopped state. Stopped. Yeah. on ball stopped. Let's call it like that. On ball stopped. Self key value. On ball stopped. Yep. Now let's listen. So what do we need to listen to? Ball at the scene at the node of the node named the ball stopped moving. We listen only stopped, so the value is 0 on ball stopped. So when the ball reports moving 0, the on ball stopped is called. Yeah, let's check it out. Alright. On ball stopped has been reported, so now we need to do what? Yeah, what do we need to do? That's a good question. Self is moving false. Yeah, let's record the state when we are actually we don't need it yet, so let's not record it. Let's remove some debug output. The ball has stopped, and now we need to move it down another track. And how do we do it? That is a good question. Game started. Alright. Alright, so the ball has stopped, and the main script needs to be needs to react. So how does it react? It attaches the ball to another track part. First it's child of that track, which is plane, then it's plane 1, plane 2, plane 3. Alright. Okay, let's call it plane 0, otherwise it's hard to script. And the same for no, that's fine. So plane 0, alright. So first plane 0, then plane 1, then plane 2, plane 3, then plane 4, 5, 6, 7, and that's the end of the circle of that that ball. So we go bow, 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 bow. So once we're done with that, we go here, then we go here, then we go, and so on. And how many track parts do we have? Main track parts number 8. Yeah, we do have 8 track parts numbers. So let's go on ball stopped. When ball stops, we go to the next track part. So we need to know current track part ID 0. Yeah, we start with that one. And when the ball stops, we increase it. We increase it and we restart the ball motion. Yeah, let's call it roll the ball. Why not? Roll the ball. Sounds good. Roll the ball. Although, why the roll ball? Roll ball, yeah, that's enough. So we do that, and then we roll ball. Roll ball. If self track part ID equals to main track parts number -1, then we need to go restart the sequence, otherwise we need to roll the ball. So when the ball is stopped, we increase the ID of the track to take. And when restart the sequence, we need to go even deeper. No, we actually need to go to the start. Alright, so first we finished the first track. Now we need to reassign the ball to the next track part. So we do it with that call. Okay. So we change the parent of the ball to the what? Okay, that's a good question. To the plane. To the plane of something else. Main plane name. Yep. Main plane name plus the ID. Okay, that's a little bit long. Main plane name. So we change the parent and roll the ball down again. Alright, let's try it. We'll roll the ball. Okay, we went like nowhere. We went like nowhere. Oh yeah, right. I forget that we need to reset its position, and its position is let's say a weird one. So its position is this and this, and we better take it as such. 05 and 03. So we need not only reset the parent, but we need to also reset the position. And alright, we can set the position with that call position. And that call, we need to assign the position to some other value, and nobody yet knows that value, even me. So before we do anything like starting the game, we need to know to record the ball position. Self ball initial position pos. For now it will be like, I don't know, nothing. Yeah, why not? No, wait. It can be nothing. It will be none. So ball initial pause. Let's record it. Self ball initial pause. You can get it from node sin ball position. Yeah, that's wonderful. And since it returns an array, we want the first value. And after that we can assign, that is, reset the ball position to its initial position. Let's make sure that we get it right. So ball initial position is already restarted. Ah, yeah, already restarted. So ball initial position, where is it? Okay, let me see. We need to start the game. Okay, there is no initial position for now. Yeah, because self cget, not just get. Alright. 05 and 03. Yeah, that's correct. Okay. We need the editor still. Not player. Yeah, ball initial position is correct. 05, 03. Although now it kind of changes, as you can see. Bam! Alright. Wait. Self-ball initial position. Well, that looks like a correct position. Ball initial pose, yeah. Alright, let's see. And go. Alright. Finally it goes down. Yeah, that took actually 4 hours. That is too much. It goes down, and then it goes down, then it goes down, and so on, and so on, and so on. And we need to restart the sequence after that. And how do we do that? Restart the sequence means it should do what? It should restart sliding, or rolling from the top. So how do we do that? That's a good question. We restart the sequence. How do we do that? I guess we simply reset the track part ID to 0 and bam, that's it. Alright, that's gonna take a little bit of time. Okay. Let it roll down. Let's have a look at it. Okay, that's too slow. Let's make it faster. Okay, we need to move it this, let's say, outgoing pipe a little bit upper. We need to also change the camera position to this. This one looks better. Let's check it out. Okay, that's better. Okay, move up. Can we move it up? Not without a problem. Alright, so what can we do to move it? Alright, let's just move it up. Okay, we move it up. That looks like enough place for the ball. Yep, that's the problem. Move it away a little bit. That cleaner base. It needs to go somewhere else, like I don't know, maybe light. No, not light. Okay, let's create some special node and place it somewhere nobody sees, or at least way below. Below, and move it there. Okay, great. Looks like it should go way below. Yeah, that's better. Okay, let's see. Okay, that was good enough. Let's recheck it. Then no, wait. Wait a second. Yeah, that would make sense to make those sliding parts a different color. Otherwise that is kind of strange that it slides on those parts but rolls on other parts. Okay, maybe if time allows we will do that, but for now it's not essential. Yeah, we are already 4 hours live, so yeah. Okay, the sequence is restarted. It goes and goes and goes and goes and goes, and yeah, it can go forever. And we can't, so let's continue. So remove excessive logging. Yeah, we don't need that logging. And that, and alright, nothing is alright. Bolt initial position, we don't need it too. Okay, we roll the ball down just fine. That is a good news. Yeah, this is good news. Alright, now we need to place the cleaner. Yeah, finally we need to place the cleaner. Let's place it. So there was the below. Finally move it. Alright, remove the below. Alright. So here's the cleaner. That is a little bit ugly. That is a little bit ugly. A little bit. Alright. Cleaner base is located where? Cleaner base is located here. Cleaner base. And cleaner base needs to be moved a little bit up, I guess. Yeah. Or that down. That up or that down. Up or down. Alright, let's move it down a little bit, like 1. Down and then down. Yep. Okay, what? -10 maybe? No, that's too much. -5. Yeah, that looks like a good place. Alright, and that is how big? Alright. That is pretty big. And that should not be visible at all from inside the cleaner, so cleaner base should be placed even, let's say, higher. So how high? I think a little bit lower. Alright, and even lower I think, and maybe even 0. No, I think 0 is not enough. Yep. Place it higher. so it can go like this low. No, we don't need that low. We need yeah, we need that low. Alright, so 90. Nope. Minus 90. Yep. That's not exactly, let's say, correct. Okay, that doesn't look aligned to me. Minus 180. That's not line 2, so I guess we need to move the base a little bit, yep, here, yep, and the same goes, alright, and a little bit here. Okay, let's save it and rotate the cleaner. Alright, that looks correct. That's not correct, or not exactly correct, and that requires okay, looks like it's not an exact rectangle, but it should be actually. The catching part is not at the center actually, looks like. Although it should be. Alright, let's check it out. So that's 2 units, that's 1 unit. Okay. And here it's 2 units and 1 unit. So 1 unit, 2 units. 1 unit, 2 units. Alright. Okay, that looks pretty central to me. Yeah, 2, 1, 2. That's almost like a center. Almost. Alright. Okay, let's make it not perfect. Yep. Why should it be exactly correct? Yeah, it's not a perfect game, so I should align perfectly. Let it align imperfectly. Yeah, why not? Seriously. This is not a perfect game. So yeah, that way it pretty much covers the hole. Yeah, so why not? Yep, I think that is pretty fine. Okay. Alright, let's move it to its initial position. That's about a little bit higher, but a little bit lower, a little bit more lower. Alright, that's 0. Let's go there. So yeah, we positioned it correctly. Let's say we did. Yeah, I think that's good enough. Okay. Okay, so we positioned it correctly, and now we need to do what? Well, first to rotate it. To rotate it, we need to select these holes, and then the cleaner should rotate to that hole and take the ball in if the ball is passing right in that hole. Alright, so first thing to do is to make only certain nodes selectable, but yeah, at first more nodes are selectable than desired. Yeah, so a usual approach would be to do this: selectable false, and so on. However, this can be done with the file too, and we just look for selectable and get rid of that. Let's check. Yep. Nothing is selectable. Nothing is selectable. That means that in the player, nothing will be selectable. There won't be a signal of selection, so yeah, it won't be selectable. Okay, now make only necessary things selectable. That's catch. That's catch. That's basically all the catch parts. All catch parts must be selectable. selectable. Alright, now let's detect those selections. You can recheck the player. Yep. Alright. So, how do we detect selection? That is a good question. We subscribe to so selection. We will do selection in main script. So let's listen to selection. It's node in the scene, but we don't know the name, so we can omit it. However, we do know the property. It's selected. So info on let's say track part selection, on catch selection, on catch, So we listen, we subscribe to node, scene, selected, key with the value 1, which means selected. And when that happens, and that only happens for selectable nodes, we will call, I mean not we, but environment to which we subscribe will call the onCatch method. Let's check it out. Yep, as you can see. Alright, let's check it out in the player. As you can see, when we select the plain part, nothing happens. When we select the catch part, it's reported. Alright, so now on that signal, we should do what? We should say we should tell the cleaner to take the ball, to try to take the ball actually. And how do we tell it? We will come up with some API. Let's call it cleaner in the scene on the node cleaner. We will say what? Let's say we will tell it to catch, and to catch what? Catch what? Catch something. Alright, for now, catch something just to make the API call. Let's check it out. Yep. No key for that. Alright, there's no cleaner constant. Let's introduce it. There's the ball name, and now there's the cleaner name. cleaner is obviously cleaner because it is named like that in here. I mean, okay, in here, yep, the name is the cleaner, okay, and the cleaner will have its own script which will result in the cleaner API. Okay, let's see where we are now on our plan. Alright, that's about, we are about in the half. Yeah, that's quite slow. We move quite slow. Alright, here's the cleaner. So we tell the cleaner catch it, and alright, let's try. Oh, nope. Oh yeah, I forgot the cleaner constant. Cleaner, main cleaner name. So the cleaner constant is main cleaner name. Alright, now what? Yep. Cleaner default cleaner catch. No provider for that key. That means that there is no API yet for the cleaner. And so let's create it. Let's create it. For now, copy the bulk API script. So it'll be called cleaner info. It won't have the, but it can have set catch, and we definitely will do catch, set catch. That's the method we'll call now when we select the track. So the name of that cleaner in environment will be the cleaner, obviously. Yeah, it needs this same name. Not sure about the ball, not sure about the move, not sure to what to listen to yet. Though we do need to provide what? The cleaner scene, and then the cleaner again. Yeah, right. Yeah. The cleaner constant equals to the name of the node, which is cleaner. So so this script provides cleaner, scene, cleaner, and catch. And we call set catch. Alright. Alright, so when we call this cleaner default cleaner catch, now we should call our new function, but only after we assign the script to the cleaner. Alright, let's see. Okay, something. Oh, yeah, right. Change the names to the cleaner. Yep. And now assign it. Okay. Okay, select. Yes, set catch is called, as you can see. And we need to catch something. That's very straightforward. Alright, so catch what? Okay, now to catch the ball, we need to rotate the cleaner, and to correctly rotate it, we need to know where to rotate to. And to answer to that question, we would use separate nodes called, let's say, point. Point 0 node will be the child of the catch 0, and we will be taking its absolute rotation and partially position to know where to rotate the cleaner to. Alright. Okay, not there, and not there. Okay, let's move it a little bit up. No, that's not a little bit, that's a lot. So ideally we should place it exactly exactly at the same point. Well, that looks like correct. More or less correct point. check the center of the cleaner. Okay, I think we need to change it a little bit, because we will need to take position, the height, and make them equal the point and the cleaner. Like that. Now we need to re-export it again. Since we are talking about an initial position, we can place it like that. Of the point to the cleaner to make it rotate to the track hole. Now in the same point, but in catch 1. Alright, let's see it. Okay, that looks correct. We have 2 points. To which cleaner should rotate to once we select the track. Okay. So now So we can tell it in the catch call to align with the point number, let's say, what are we passed in the catch? Let's see again. Okay, we passed in the number 1 selected. Yeah, we are past the name of the node we do select, so we can pass the index and that's enough. Yeah. For example, yeah, the index. Let's pass the index. Okay, let's commit. Before the cleaner catches, the cleaner faces the track, the selected track. Yeah, that's where we stopped. Okay, forget one file. Okay, so where we are at now. We created a new project, posted to GitHub. Yeah, current progress can be located at GitHub, at OG Studio, at Rolling Ball OSG. No, OGS. That's everything I've done so far. And we are at where? Alright, create selection point nodes. We are here. And now we need to rotate the cleaner to face the tracks. Yeah, that's actually half the way through. So unfortunately it took me 5 hours instead of planned 3 planned, and that's taking a little bit too long. So it's taking a little bit too long. So we're going to finish this live session in the next weekend, Saturday, yeah, Saturday. Hopefully, yeah. The next part, the second part, can be done in 3 hours. Okay, so that's it for now. Thanks for watching the first part of the live session. The second one will be on the 6th of February, where we will finish the rolling ball game. Yeah. Sorry that we couldn't make it in 3 hours. See you in the Saturday for the second part of the live session, and earlier for watching me coding. Thanks for watching.